All right, so now we're going to do one more type of shape. So let's think about the triangles that you kind of create from a picture like this. So again, this 5 is the radius. It goes from the center to a corner, and what we need for our area formula is the apothem, and we don't know what the apothem is. I guess we don't know what the side length is either, so we don't know what the perimeter is. So we're going to do the same type of thing that we did for the last problem, which is we're going to draw another radius in, and you're going to see this triangle that we have over here. And I want you to think about the angle made in the center of this shape. So we're breaking into 3 triangles, so we're going to do 360 divided by 3, which is 120. So each of these triangles in that corner around the center is 120 degrees. And why is that important? Because again, we're going to take this triangle and we're going to cut stuff in half. And when you cut 120 degrees in half, we're going to get another one of those angles that we know how to work with. We're going to get something with a 60-degree angle, which we can turn this into, let's draw this one more time a little bit bigger here. We can turn this into a 30, 60, 90 triangle where we're going to be able to find the apothem, and it's also going to help us find the side length. So again, I'm just going to draw this thing over and over again because I'm not doing a very good job of drawing it. The central angle was 120. We cut it into 2 pieces, which is 60. The radius, which goes from the center to a corner, was 5 long. And we need to find our apothem, and we need to find this side length down here. Which, looking across from the 30, how do we get from 5 to our short side? We divide by 2. So our apothem, our short side, is going to be 2.5. I'll put that in our area formula, 2.5. And how do we get to our long side, which is half of the side of the triangle? We multiply that by root 3, which is 2.5 root 3. So how are we going to get the whole side? I hope you're thinking, well, it's cut in half, so we just double it. So each of these parts is 2.5 root 3. You can either think about adding them together or multiplying by 2. So the side length of our original triangle, the thing that we're trying to find the area of, is 5 root 3. And how do we find the perimeter? We take the side length, 5 root 3, multiply it by the number of sides, which in this case happens to be 3. So finding the area, we do 1/2 times 2.5 times 15 root 3. And again, if you're going to use your calculator to help multiply these things, do everything besides the root 3. And it looks like we get 18.75 square root of 3 for area of this triangle. Now, you're definitely going to want to go back, think about these things. If you were just kind of following along and writing things down, go back to the start. Think about when you're given the apothem, pretty straightforward. When you're given the radius, you have to do a little bit of work. And then in shapes like the hexagon and the triangle, if we cut our triangles into these shapes, we actually get 30, 60, 90 triangles so that we can solve for side lengths and apothems, even given only one measurement. Given one measurement, we can still find the other 2 pieces. Now, finally, to wrap things up, if you think about a square, when we cut those triangles into this shape, you know that we get like 45, 45, 90 triangles. We've done that a whole bunch. And you might think to yourself, okay, we're given that shape. Finding the apothem won't be so bad. But instead of doing it this way, anytime you're given a square, it's going to be easier to remember the area formula for a rhombus instead of trying to do find the apothem and the perimeter. Look at this triangle, or excuse me, the square that we're given. If you're given the radius, which is 10, it's easy to think about, well, the whole diagonal is 20. And if you remember rhombus properties, which are also square properties, the diagonals, excuse me, that's not a rhombus property, that's a rectangle property. If you remember our rectangle properties, which a square is a rectangle, the diagonals have identical lengths. So both diagonals are 20 in this case, meaning we could do the area formulas 1/2 times 20 times 20, which is 200. And then look at our last shape. You're given the apothem. You definitely could think to yourself, well, I could use 1/2 times apothem times perimeter, because we see the apothem's 10, and you can kind of put together the idea that a side length is 20 and find all the way around. But wouldn't it just be easier to remember that for a rectangle we could do base times height? The side length is 20, the height is also 20, and we can get 400 very quickly instead of having to do 1/2 times the apothem, which is 10, times the perimeter, which is 20 times 4. So when you see squares, there are easier ways to do it than using that regular area formula. So now with these done, you have your homework to work on. Tomorrow we'll be doing more of this stuff, but we will not be using special right triangles to find some of the lengths. So we'll be continuing the same types of things, just instead of special right triangles, we're actually going to be using trigonometry.